Algebra 2 Honor 7.4, and this is day 1. We'll have an assignment from the book, and then there'll be a worksheet for the second day. And you're going to be adding and subtracting rational expressions. And so this is going to be involving getting common denominators in order to add or subtract. And so they are talking about that in the core concept. In order to add these fractions, the denominator needs to be the same, and we keep that denominator, and then we just add their numerators. Or if it's subtraction, we keep that denominator, and then we subtract the numerators. So in example 1, we have rational expressions because we have polynomials in the numerator and denominator. But the denominators are the same. So when you're doing these, make sure you write down the original problem and then work down the page and put an equal sign. And right here, since we have the same denominator, we just keep that denominator and we add up the numerator. And the answer is just going to be 7 over 21x. But then look to see, can you possibly simplify? Yes. And 7 goes into 7 once, into 21 3 times, so you get 1 over 3x. And from the get-go, x could not equal 0, and that's still the same in that final expression there. So domain, all reals except for 0. All right, part B, we're subtracting, but again, we have a common denominator of x minus 5, so we keep the x minus 5, and we subtract the numerators. And now they have no common factors, and so that is the end answer. By the way, sometimes when people start doing these, they forget rules and they think, oh, those x's can cancel. You can't cancel, not with addition and subtraction in either the numerator, denominator, or denominator. So that doesn't simplify anymore. You can't cancel those x's. So that's it. And the domain has not changed from the original because from the get-go, x could not be 5. It was all reals except for 5. We can't let that denominator be 0. And that hasn't changed, so that's it. Now, fractions aren't always going to have the same denominator. So we're going to have to be able to look at the denominators and determine the least common multiple. And so on this one, right here, the core concept is if you have a denominator here and here, at least C times D is the common denominator. But we're going to find that it's a little more involved in that. So we're going to be looking at that. But once you get them to have a common denominator, and they showed to do that, they multiplied the first one by D over D, and they multiplied the second one by C over C. That's what you're going to be doing. You're going to need to show me what you're multiplying each fraction by in order to get a common denominator. And then the same with subtraction, but only you subtract the numerators. So in example 2, there's homework problems where they're going to be listing this 6x squared minus 54, and then this 9x squared minus 54x plus 81. And they're going to want you to figure out the least common multiple. And I often say LCD, least common denominator, so I kind of use those interchangeably. And so, just a second. And so what you need to do is factor those. So we're going to take 6x squared minus 54, and we're going to take out a 6. And then we need to realize, oh, x squared minus 9 still factors x plus 3. Sorry. X plus 3, x minus 3. So those are the factors for it. So then for the 9x squared minus 54x plus 81, you can take out a 9. And then that factors into x minus 3, x minus 3. But we need to kind of explore these a little bit further. 6 is 2 times 3, so we've got it down to prime factors there. And 9 is 3 times 3, x minus 3. Or I'm going to think of that as 3 squared x, oops, I've got an x minus 3 on there, x minus 3 squared. So now we need to take each factor that we see, and we have to take it the number of times it repeats the most in any one term. And so I see, for that least common multiple, I see a 2 in the first one. I see a 3, but in the second one it is squared, so I have to take it to the highest power. Then in the first one I see an x plus 3, and then I also see an x minus 3 in each of them, but x minus 3 is squared. It is in there twice, so I have to take it twice. And that's my least common multiple. So 2 times 9 is 18, and we'll leave it 18. Just leave it factored, x plus 3, x minus 3. Don't multiply those out. And that is my least common multiple. And that is what you would need each of the denominators to become. All right, so in example 4, we need to find the least common multiple. Excuse me. And so 12x squared, well, 12 is 4 times 3, or it is 2 squared times 3, and it is times an x squared. And for x squared plus x, take out an x, and we have an x plus 1. And so now I need to look at factors in each of these and see what they have in common. Well, the 12 is unique to the first one, so that 2 squared times 3 is going to be part of it, or just 12 is going to be part of my least common multiple. And then I see x in each of those, but in the first one it is squared, so I'm going to need to use x squared. And in the second one I have an x plus 1. And so my least common multiple here, which is going to be my least common denominator, is going to be that 12x squared x plus 1. You don't want to get one that's too big, more than what you want, because then you're going to have more simplification to do at the end, and it's going to be harder. So now, I said in the directions, I didn't talk about it, but I said, show what you multiply each fraction by in order to get common denominators. And you're going to need to do that here. So I'm going to model exactly what I want. You won't see this in the books worked out solutions, but I want it. And so you're going to need to leave some space. We have 8 over 12x squared. And for the least common multiple, it's missing the x plus 1. So you need to take the top by x plus 1 and the bottom times x plus 1. And then in the next one, I need to realize that that denominator is already x times x plus 1 in factored form. So what is it missing? Well, I need it to have an x squared, so I need to multiply it by an x, and I also need to multiply it by 12. So you need to make it take it times 12x, and you need to take both the top and the bottom times 12x. So it becomes that 12x squared x plus 1. So now the denominator in each of them is 12x squared x plus 1, and we're just going to leave that factor just like that. And you're going to add up the numerators. In the first, I have an 8 times x plus 1. And in the second, I have x times 12x, which is 12x squared. So distribute that 8. And then from there, I see in the numerator, I could take out a 4. And when I do that, I have a 2x plus 2 plus 3x squared all over 12x squared x plus 1. And that 4 can go into that 12 3 times. And I can write that trinomial in the numerator. I want it in descending power. So 3x squared plus 2x plus 2 all over 3x squared x plus 1. And you cannot cancel those 3x squared. Because in the numerator, it's being added to things. And when it's being added like that, you cannot cancel those. And so it is possible that that numerator could factor. But if I look at, and I'm just going to bring that numerator, I'm going to copy it, and I'm going to bring it to a different page. If I look at that numerator, we have that discriminant that can help us find out if this is going to factor for us. So we have 2 squared minus 4 times 3 times c, which is 4 minus 24, which is going to be less than 0. So this does not factor over the reals at all. And so I don't have to worry about that numerator factoring and canceling with anything. And there is my simplified answer. All right, in example 5, we again need to find that least common multiple. So we have a least common denominator. And so we have this x squared minus 3x plus 2. And that factors x minus 2, x minus 1. And for the 2x minus 4, I can take out a 2 and I have an x minus 2. So the least common multiple for those, which is going to be my least common denominator, is going to be, I have a factor of 2. I have x minus 2, and the highest power I see it in either one is to the first. That's all I need. And then I have a factor of x minus 1, so I need all of those. So as I write this first one down, I'm going to factor that denominator into that x minus 2, x minus 1, and I'm going to be looking for what is it missing. And it is missing 2 from that least common multiple. So I'm going to need to put the parentheses in the numerator. I'm going to take 2 over 2. I'm going to take the numerator and the denominator. You have to distribute it across the numerator. That's why we need those parentheses. And then for the second fraction, I have 2 times x minus 2 in factored form in the denominator. And I have a minus 2x minus 1. And on that one, I am noticing that it doesn't have x minus 1. So I'm going to need to multiply by x minus 1, top and bottom. But in the numerator, I'm going to need parentheses there and multiply those. And so I've got my common denominator. And I can go ahead and distribute that too. I get a 10x minus 2. But I'm going to have to be a little bit more careful because I'm going to need to FOIL that minus 2x minus 1 times x minus 1. So if I distribute the minus 2x, I have a minus 2x squared. I get a plus 2x. If I distribute the minus 1, I have a minus x plus 1. And so I have 10x minus 2. And I'm going to collect like terms before I distribute that negative. And then I'm going to distribute the negative in the numerator. And then in the numerator, I can write that as a 2x squared plus 9x minus 3 all over 2, I forgot a parenthesis down there, x minus 2, x minus 1. And again, I can check out that discriminant, b squared minus 4ac, just in case that numerator might factor for me. And that's 81 plus 24, which is 105, which is not going to factor over the rationals because square root of 105 is not a perfect square. or 105 is not a perfect square, and so therefore that's it. Now, we haven't had anything canceling, and so I haven't changed denominators at all. Example 4, from those factors of x and x plus 1, x could not be 0 and x or 1, and that's still true in the end answer. And in the end answer for example 5, from the get-go, from how those factored, x could not be 2 or 1, and that's still true in the final answer. So we always have to kind of check for that, because if something canceled out and I lost, and it looks like something else could be in the domain that can't be, I would have to make sure I stated that. All right, so anyway, I have some down here that you can try. So I suggest you turn it off, the video, pause it, and go through this and work on it. That number 8, I'm going to even move it to the next page. It takes a little bit of room there, so just FYI, you might want a little more space for that one. But I suggest you just pause it, you try these, and see how you do. All right, so in number 6, you have a 4x and a 7, so the least common denominator is going to be 28x. And so I have a 4x, but I need to multiply the first one by 7 over 7. That's what I want to see. What are you multiplying each fraction by? And for the 7, I need to multiply the top and the bottom by 4x. And so I get that denominator of 28x, and 3 times 7 is 21 minus 4x. And you can't simplify those, because in the numerator you have subtraction, and 21 and 4 do not have any common factors that you can take out that would cancel with 28. And so that's it. That's as good as you can do. And the domain was all reals except for 0 in number 6 and at the beginning, and that's the same with the end answer. So, we're good on domains. All right, on number 7, you need to look at this as factoring x minus 4, x plus 3, and I'm going to leave a little space for what we have to multiply by, and then 5 over 12 times x minus 4. So this is missing 12, and the second one is missing x plus 3, so we need to take the numerator and denominator times x plus 3. And so our denominator is 12 times x minus 4 times x plus 3. And in the first fraction, we get a 12x when we multiply, and plus, distribute the 5x plus 15. And so we have a 17x plus 15 all over 12, x minus 4, and x plus 3. And that there's nothing that I've canceled, and from the get-go, x could not be 4 or negative 3, and that's the same down here. So this looks good, just like that. All right, for number 8, I am going to copy that and move that down here so I have a little more room. Okay, so my least common denominator, or multiple between the 3 denominators, is the product of all of those, because they're all in factored form. There's nothing to factor in the denominator. They already are factored, so you need each of them. So what that means is on the first one, and since these are binomials, I'm going to put them in parentheses, and you need to do that too. I am missing in the denominator both x and 2x plus 1. So I need to multiply top and bottom by those using those parentheses. You can put parentheses around the x if you want as well. And then plus I have a 4 over x, and it's missing both x minus 2 and 2x plus 1. And then in the last one, I'll put that denominator in parentheses since it's a binomial, and it is missing the x and the x minus 2, so I'm going to need that in the numerator as well, both of those. So that's what I mean. I want to see what you're multiplying each of those by. So now they're all going to be over x, x minus 2, and 2x plus 1. Notice we're not multiplying out the denominators, we're just leaving them in factored form. And so I'm going to have an x, and I'm going to go ahead and multiply those two out. I'm going to get 2x squared. I get a plus 3x in the middle, and plus 1. And then a 4, and I'm going to go ahead and multiply these out. 2x squared minus 3x minus 2. And I'm going to write this last one as 3x squared x minus 2. Caution you when you are subtracting that you distribute the negative all the way across. So now we have a 2x cubed plus 3x squared plus x, distribute the 4, 8, x squared minus 12x minus 8. And this is where I'm concerned, not so much for the first one, that usually goes just fine, but you have a negative 3x squared times a negative 2 is a positive 6x squared. Did you do okay? All right, and so now I have a 2x cubed and a minus 3x cubed is a minus x cubed. 3x squared, 8x squared, and 6x squared is 17x squared. A plus x and a minus 12x is a minus 11x, and a minus 8. And from the get-go, x could not be 0, 2, or negative 1/2, and that's the same here. Nothing's canceled out, and that's my answer. Be sure that you copy the original problem down, that you show on each fraction what you are multiplying by clearly, that I can read it to get the common denominator, and always on each step have a full, complete statement. It should be equal to the step above always. And then don't forget on each line to start with an equal sign.